Good day to viewers at home. This is Energy Class, and in today's class we'll be looking at one important subject called mathematics, and in that class we'll be looking at indices as a topic. But before that, we need to understand that indices is a form of figure on its own. Just like we have some other form of numbers like 1, 1, 0, 1, 1, 2 happens to be a form of number called number base. We also have 2 all over 3, which is called a fraction. And in this, we also have if 2.135, for instance. This is called a decimal. Or we call it a decimal figure. Alright. So also that takes us to what we have today, which is if you have 2 raised to power 2. This is called an index figure. So this is where we are going today, but you need to understand that we form this number by bringing this collection of numbers like 1, 1, 0, 1, 1 base 2 to form a number called number base, and 2 divided by 3 to form a number called fraction, 2 with some other number here, but in between we have decimal, and that form a decimal figure. Just like this, which is what we need today, happens to be a number like 3 raised to power 2 to form an index figure. That 3 raised to power 2 is formed by multiplying the same 3 in 2 places. Multiplying 3 in 2 places to give us this, and that is what forms this index figure. But let's go to the explanation proper about indices itself. Look at this properly. Just look at it before I move to the next explanation. Alright. Now, if we have 2 times 2 times 2 times 2, to write it in index form, how can we write it in index form? It gives us 2 raised to power 2. It gives us 2 raised to power 4. We count the first 2, the second 2, the third 2, the fourth 2, and that is how we come about this. If we have x times x times x times x times x, that will give us what? Let's count this: the first x, the second x, the third x, the fourth x, the fifth x. Obviously, the way we deal with this, it will result to x raised to power 5. What of a situation whereby we have m times m times m times dot 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 times n? what does that give us? If we number this to be the first M, the second M, the third M, and it goes on and on to the last M here, because we may have many numbers, many of the M's in this context. So therefore, if we tag the last one to be the N, right, N of M, so it means that we'll be writing M to the raised to power of N, just like the way we described this to be that the last X here is the fifth M, is the fifth X, and that gives us X raised to power 5. And the last 2 here is the fourth 2, and that gives us 2 raised to power 4. Now, let's describe this as we have M raised to power N. What we have here is called power, or we call it index, And what we have here is called base. Please try to learn this, the language under this topic, and that is altogether the base and the power will give us an index figure. Now, 2 or more of these index figures give us indices, meaning that the indices is coined from the plural of index figure, and index figure means indices. That is, means the plural of index figure means indices. But in other words, we can say that indices is a repeated multiplication of similar figures is a repeated multiplication of similar figure. So now, meaning that if example, if we have 2 raised to power 7, this means 2 times 2 times 2 times 2 times 2 times 2 times 2. So you can see by repeating similar figures, which happens to be 2, here we are able to obtain this figure called an index figure. That is the meaning of, that is what indices look like. But why indices? We'll be looking at how to multiply, divide, even add and subtract indices. But before we can understand how to multiply or divide indices, we need to study laws of indices. But in today's class, we'll be looking at just a particular law in indices, and how can we solve challenges under this. We'll be looking at it. So let's go to that in today's energy class. Now, the next challenge is laws of indices. Laws of indices. Now, in laws of indices, let's look at the first law. First law. So, if I state the first law to be x raised to power a times x raised to power b, it is stated that this will result to x raised to power a plus b. X raised to power a plus b. In other way, we can write it to be x raised to power a times x raised to power b times x raised to power c. We can have many of these index figures like that, times dot. It means that this will result to x raised to power a plus b plus c plus dot. It goes on and on like that. So, meaning that we can have more of these index figures being multiplied together. Examples. Let's say, for instance, in an example like simplify 2 raised to power 3 times 2 raised to power 5. So let's have this to be the first example. If you have another one, example 2, like let's have 3 raised to power 6 times 3 raised to power minus 4. And in that, how can we solve this? It's very simple. Solution. The first one, 2 raised to power 3 times 2 raised to power 5. Looking at these figures, it is comparable to what we have in the first law here. So we can write this question in this form. So that gives us 2 raised to power 3 plus 5. And that results to 2 raised to power 8. If we add this together, it will result with 2 raised to power 8. And that 2 raised to power 8, if we multiply it together, it will result to 256 as the answer. But what of if the figure is much bigger than this? All we need to do is to leave our answer this way, because sometimes it may be raised to power 20. It means that we have to leave our answer in as